Okay, so today basically we're going to learn about threading. So we already went through making this whole hammer handle, and now we've got to make the thread. So this is a pipe thread threaded into the hammer handle. So the more you turn it, the tighter it gets. I did pipe thread on purpose because I could have probably done a regular thread, I guess, but I wanted to make sure the hammer is going to get hit a lot. I want to make sure it didn't come out. So the more you thread it in, the tighter it gets. And I also said put red Loctite so it's non-removable and stays in there forever. Basically, the threads over here, I tried to label them so they are 3/8 MBT. So 3/8, what that means is a 3/8 pipe. So on a pipe, the 3/8 is the ID. The OD is basically however thick the wall is on both sides added to this. So 3/8 is actually more like 5/8 diameter. Okay, so the drill on this thing, it has to be a 9/16 drill 3/4 inch deep into the hammer head for the and then you turn in the threads 13 times, and we'll be doing some of that manually here in class in the month of April here. So typically when you do threads on a tapered, it's 11 to 13 turns. You basically spin your handle 13 times. That's how deep it's supposed to go. 11 to 13. I went 13 or tried to do 13 just so we could get a little bit more engagement on it while it's in there. Somewhere on here, I thought I talked about the minimum. Oh, there it is. Okay, so this is for, this threading is actually for the acorn nut that's going to sit on the other side of the hammer handle. So it's a 5/18. And while we're talking about threading, you notice that this 5/8 would be, of course, 0.625, and that's going to be the major diameter of the thread because you talk about the outside diameter is the same as a bolt, right? And it's got 11 threads per inch, so that's your pitch. So, or 1 divided by 11 would give you your pitch, whatever that number is. That's for the acorn. That's not the one we're doing right now, but that'll be the next one. And there's a minor diameter on that acorn one. Okay, so that's how much it is on the small part of the teeth right in here. That's the small part diameter. Okay. Canvas is down, so we'll just be basically using these drawings to do it. How far does it go? I think I went ahead and just put that on the drawing on this one because it got a little complex with the tapered threads. So we're basically going to add it to the drawing. So this is the final drawing you want to come up with. I'm going to help you redraw it, so I'm going to open up my other one as well that we just did last class, hopefully. If I can find it. Okay, so we're just going to do this one step at a time, all right? First thing first, so this is where it's going to be cut out with threads, right? So we need all this information in here. So we're going to offset it down 303. I guess we have to offset to the right first, okay? And then we'll offset down, and that'll give us all these numbers. So it looks like I went over 0.125 to the right, so 1/8 of an inch. So the tool that you use to cut these threads, it has a width. So you can't necessarily just basically go right over to the edge. If you go right over the edge, you're going to break it in half. It's basically a pointed tool, right? And it's got a width on it. So if you basically go all the way to the edge, you just break it in half. So you got to go to a certain point. So that's what it's really more like 1/8 of an inch thick, which means I'd have to be a 16th over. But just to be safe, I went over a whole 8.125. Right. So on your hammer handle, on the part that is to the that looks like it's tapered, right, like this handle right here, we need to offset that line over 0.125 over. Okay, so over offset 0.125. All right. Grab your line and bring it over 1/8 of an inch. All right, that's our first one. And then the next one, it looks like I went over 1.4375 would be the number. So, all right. So that's basically 9/16. Yeah, 9/16 over, I think, which sounds about right. So that's 4.375 is 7/16, and this is 2/16 back. So I added them together, and I got 9/16. So we're going to offset that one over. The one we just did offset it over 9/16. So I'm going to repeat the command. and it wants to know how much 9/16. Okay, and you could type in 0.5625 as well, but it's easier to type in 9/16. We're going to pick that number and pick this side. Okay, so now we've got our two cutoff points. If I did my math right, 8:30 in the morning. Who knows if I did it right this early in the morning, right? And now we're going to offset it down. Okay, so I think I offset. So what it gave me is it gave me the major and minor diameter in the big Blue Book Machinist. So basically, I'm going to offset this up 303. Okay. Then copy that line down, and that'll give me all my points. So that is pretty tricky, but let's just do it together, and hopefully it won't be too bad. So the center line, I'm going to offset that up 303 is the next step. So offset 0.303 for the distance. And I'm going to bring this one up here, okay? Now the tricky part. So one thing I could do is I could copy this down through here. There's a command. Usually when we do offset, we do a number, right? Well, this time we're going to do the default, which is actually through, okay? So I'm just going to hit enter to finish offset, enter to repeat it. And I'm going to pick through on here, which I think is, I don't know, I'm using 2021, so they changed a few things, but I'm going to pick through just to make sure I got it, okay? Now it's basically looking for a select object, okay? Now it wants to know a point to go through. Well, there's a point right there, okay? So you make sure you have your snaps turned on if you don't. So in AutoCAD, most of you probably don't. You might have them on, I don't know. Make sure snaps are on, okay? And then object snaps. And then basically pick this point, the intersection point, okay? So now basically, so this point's critical right there, and this point right here is critical. And of course, so this will be the beginning and the end. So on this threaded one, we can't actually start earlier because there's metal everywhere. So we're actually going to put it up, we're starting where we're starting and ending where we're ending. Usually if you're doing threading, typically whenever you can, like on a bolt, you want to start off before the beginning and end past it if you can, because it's just, it gives you, make sure you're enough, but a lot of times you can't. It's got to be threaded where it's got to be threaded, and so we're just going to start where it starts and end where it ends. So there's no safety in this one. And there doesn't necessarily need to be. We're going to start out about a little bit higher. It's like a couple thousandths higher. No, we're going to start right on the money. Okay, so hopefully it's designed right, and it'll be going in. It doesn't go real fast, so it'll be fine. It's so pointed. All right, so now we're ready to add all these dimensions. Okay, so let's get rid of the extra lines and trim it out, and then we'll add all those dimensions to make it look like that. So we can get rid of that green offset line. That was just a construction line. Okay, we can get rid of that, delete it out of there. Okay, and we can trim off the bottom of these two. So TR for trim on the old AutoCAD, enter again on the new AutoCAD. You can just pick it. I'm getting rid of all these excess lines. Okay, so now I've got my little trough in here, right? Now I'm going to hit enter to finish trim, enter to repeat it, and now pick this line for your cutting edge. Now I can't, on 2021 you actually got to pick cutting edges, but on yours you can just pick this line for your cutting edge, and then get rid of the ones above it. I should have hit enter and pick the ones above it. Okay. So if you just pick trim the fast way, you'd have to get rid of all those stupid little things. So that's why you want to pick a cutting edge. Okay. All right, I think we're getting close to matching this one up. But I usually say don't draw off my layout drawing right, but this time kind of making you do it. There's just all these, like I said, all these numbers pulling out of that book, a little tricky. I think that's it. I think we're just ready to add all those dimensions. Now notice a couple of them. So this one here is dimensioned from the intersection point right there, and it tells how much it tapers over the distance of the thread. So that'll be our R value that we'll add to the end of our G32 code. That tells it basically is a tapered thread and makes it drop that much. And I don't remember if it's a negative or positive. Probably is a negative, but I'll have to look that up when we get that far, because I don't really remember. But basically that's going to give us our taper. And then these are all going to give us our start and end points. So it's going to so this 330 is just right here. We're not even really using that. So I made all these different color because they're the ones I'm going to use. So there's my Z endpoint, right? That'll be telling you where I got to go in Z. This will be my Z start point, okay? And this will be my X start point, And then this will be my X finish point. Notice it's at the upper end because what it does is it adds the taper or subtracts the taper from it, however you want to look at it. Okay, so it's going to subtract this much from that to get to this point, and it'll do that automatically. Okay, so dimension it just like I've got there. So we go back to the hammer handle. Make sure your UCS is up here, which mine is not because I must have done it later. So I'm going to go UCS, enter, and I'm going to put it right there on that center. Yours might already be there. If you see the XZ in there, then I hit enter when I get done. You can't hardly see it, but make sure your XZ is in there because this thing's yellow. Change that color. There, now you can see it a little better. Okay. All right, so I'm gonna add all my dimensions. So most of them are, the first one is a linear dimension from here to here. I hope I got it in the right layer again, or at least the right color. So I'm gonna switch it to different colors because I know it's different. So maybe cyan or something bright that we can see. And then first one's a linear from here to here, right? It should be 17 if I did it right. And it's up in the part where I can't see it very good. So I just finish it out, touch it, grab that grip and drag it down. So I can see a little bit better, okay? And the rest of them should be all ordinate dimensions, I think. So switch it over to ordinate. Remember, the ordinate doesn't work unless you move the UCS, okay? And I don't need this one here. I just need this one in the Z, which is normally the X, but not in lathe programming. I need both of them, and I need my start points and my finish height, okay? That's my finish height there, and then this one's important too. So I just keep hitting the enter to repeat that. So that's my start height, my finish height. I don't know why it's 1,000 different this time compared to 2020 or whatever, but I'm not going to get too worried about it. It's a tapered thread. It's going to get tight the more you thread it. So it looks like I had 3,051 in this one, 3,050 in this one. Everything else seems to be the same. Okay, that's it. Hopefully your handle looks like that. Okay, now we're ready to add those that threading to it. Okay. Really, those are the only numbers we're going to need, I think, too. Okay, so now go ahead and open your program, the one we did before. We're going to add it to the bottom of the handle. So we'll open up the lathe. And looks like it's brought up my last program, which is sweet. Yours probably won't, unless you use your laptop like I am. Okay. And it won't remember the sizes. Mine is, unless you use your laptop again. So we'll have to set them up. So let's go ahead and do that together. So basically, if you go to open everything up, and I'll leave that screen open for just a minute too. So if we go to the verify and verify settings, okay, the only thing we really changed was the stock size so it looked right, right? We changed it to 1 inch diameter and 11 1/4 long. We didn't change anything else. Okay, and that just makes it look right. Okay, I think everything will be fine. Besides that, it should be in the right workspace and everything if you open the old program. Clean up my program here a little bit. All right, got to edit and unlock your program, right? Okay, let's see if we can do like a bunch of split screens here. Get this to work. Come on. Let's see if we can grab it. Okay, so there's my numbers. I'm going to go ahead and open up the lathe threading example and use that to program it. Okay. So we're going to basically use that to figure out our first line of G32 code, okay? But basically our program is going to be very similar to this one, okay? So at the end of your last finish cut, all right, so that's why we did this as a second part, so we can go straight into the threading, okay? So that's remember from last class we tapered it down here, and we did all those circular interpolation G2 and G3s to cut out those handles for your grip. We did those first, and then we did this part second. So now we're basically ready for the threading part in the right spot and everything. So right at the end of the last finish cut there, where it does spindle off, before this is the shutdown sequence. M5 is the shutdown sequence, goes to safe position, ends program, right? So right before that M5, right after your last finish cut, put a couple enters below that, right? So we got room to do everything. And then up here, then we're going to start typing, right? So the M5 shut spindle off, turn your caps lock on, and just kind of repeat those first ones, semicolon. It's a good idea to type all this stuff in, because that way when you take the final, you're not lost. Shut off spindle. If it helps you remember it. And then we're going to go to the safe position, G0, X2 going 2 inches up, and Z4 is going to go 4 inches over from our part reference serial. So that's tool change or tool safe position. All right. And then we're going to go to M6T5, so M6T5. Okay, and that just says change tool. Change to thread tool, which is a tool 5, right? And then the next one, and that's right on your sheet that you guys have too, right? I'm just copying right off that thing. M3 S250. So that's going to say, okay, now turn my spindle on, and we're going really slow this time. I usually go 1500 or 2000, but on threading we go slow, 250 RPM, right? Turn spindle on. 250 RPM. Okay. And then now we had that G4 in there, G4 F1. So that G4 is just a timer. It sits for a little while, so dwell for 1 second. The F1 gives you 1 second. And then we're gonna go to our first position. Okay, so this is where we're gonna shoot on down to that G0, not O, G0. So we're going to go down to this 350 or 351. I guess we'll do what we're doing in this class. So did everybody else get 350 or did everybody get 351? All right, so we're going to go 350. Okay, so that's G0 X.350, and that's where it will go back to every single time that we do a G30. So this is your beginning position for every G32 until you type the G80 to end the can cycle. It will always go back to this position. It always goes back to the beginning part. And then the Z is, did I forget to do the Z? No, there it is. Z is 1.438, or actually it's 1.4375, but our machines aren't that accurate, so whichever way would be fine. 4375. Be crazy accurate on it. Okay, so that's the beginning code. All right, now the next one we're going to, that's the start position. Start position for threading or thread. Okay, and it is good to put notes when you write a program, because you know you're not the only one looking at this. You got an operator trying to read it half the time. So if you're writing the code, especially if you're going to make 1 million parts, put some notes in there. All right, now we need just the M0. So the M0 is going to sit, just basically it's a stop. Stop for check. Just to make sure it's in the right position. The G4 up here was a dwell for 1 second. The reason for that was basically so the machine had time to calculate that it's the right position for it to start. So it's actually tracking the RPM and knows where it starts every time, because the thread can't start like at 0 degrees on the thread and then 90 the next time. It has to start in the same position on that bolt or whatever you're threading every single time at the exact same point on it. So if you drew a mark on the end of that bar, it'll have to start threading there every single time. So it's tracking it. Okay, so it's got to be really accurate. That's what that, well, it gives it time to actually calculate that the first time. M0 stops to make sure you start it, so you make sure you're actually over in this spot. So you'll look at it and say, yep, I'm there. And then you'll have to tell it to go. Okay, now we write our first G32. So we're going to go up here to the G32 and try to write it right here. See if I can type it in. I think it's at negative. I'll check it here in a second. So before we copy a whole bunch. So we don't put in the end code because it's going to type that by itself. So it's just G32. And our target point, we're just going to tell it where it's going, just like all our other G codes. It's going to go to 875 in the Z and 303. Okay, because remember the negative 17 doesn't get dropped off because of the taper. So we need a G, and the X value would be 0.303, right? And then our Z value is way over there. I just had it 875, 0.875. Okay. And Q0, because we're going to go one pass on each one of these. Okay. So you'd go more than one pass if you're threading like a 3-inch thread or something like that. You'd repeat them, so you have to type so many. But otherwise you don't. And then F. So the threads are. Now we got to go back to the hammer handle because I don't remember. It's a 3/8 something. 3/8 18. Okay, so that's 3/8 18. So it's 18 threads for every inch long. All right, so somebody get out a calculator for me and tell me what 1 divided by 18 is. Because I don't know, and that's going to be our F value. So
0.05 repeating.
Okay, so we'll take 0.0556, and that'll be accurate enough. Okay. Okay, and then now we need to add our R value. Since it's a taper, you add an R for however much it drops over that thread. Okay, so that'll be an R and negative 0.017. Okay, it's that number right here, right? Okay, now I think that's the right code. So that's let's go down here. So this is the first. So this is the thread cut. Okay, on Canvas I told you how much to subtract every time, but Canvas is down, so I pulled up the program from a year or so ago, and we had 51 there. We got 50. It's good enough, right? So basically, we're going to repeat these numbers. So I'll show you how to do that real fast. So you basically just put a bunch of spaces in here, all right? You got plenty of room, and then you're going to copy it. You just shrink this down so we can see everything. You're basically going to copy this line down repeatedly until you get enough of them. So we need, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we need 12 of them. So just highlight that like that, Control C, put it below it, Control V, Enter, Control V, till you get 12 of them. Okay, and then basically, as you notice here, I took off a little bit less every time. And the book tells you how to calculate this. I'm not going to go through all that. You have to do it for your homework anyway. It is a little bit of a goofy formula. It will not usually be right on either, because there's so many variances in your machine power and everything that you'll usually have to go in there after you run one and change these numbers. So, but the general idea of it, though, is you take off a lot more in the beginning, and at the end you take off hardly any. A lot of times you'll see them even repeat the same last number because it'll clean it up in like a finish cut almost. So you'll see like ours is 303, they'll even repeat that. Now I didn't do that because we've got trying to get the whole class through it, right? But so now you want to change all those X positions to match what's written right here, okay? It looks like I typed the wrong number in the first one. That would have been really bad. 350. Okay, so this is my go-to position. It should have been, the first one should have dropped 11, okay? So you want to basically change the X values to match all these, okay? So change all those X numbers. So I'm going to do it too, so I'll probably pause the video while I do it here. Okay, so we've got all those in there. I'm gonna close this back out because we're done with that now. And now we've got to finish out the finishing codes, which I think the only one is a G80, right? So remember, you got to type that G80 so it quits. Now, really, it wouldn't be so critical since it's the end of the program, but something has to tell it you're done. Okay, usually and that's the G80. It says end can cycle, and G32 is just a fancy can cycle. End can cycle. So you guys in this class are learning the main G codes. There's a lot of them out there, but this is, the ones that are used 99% of the time. But you can actually write macros too to create your own G code on most CNCs nowadays, which is kind of neat. So you could write your own can cycle G code that will do repeating steps if you have some that are repeating. So if you enjoy doing that stuff, some people really do after they get into it. It's neat watching it happen. And G coding is done more than just on CNCs. 3D printers write G codes too. So if you write a code for a 3D printer, you can go in there and change those numbers to what you want. You can put an M0 in it, stop in it, stick like a nut in the plastic, and then print right over the top of it. So like you'd have something to thread into, made out of steel. I mean, there's all kinds of things you can do, knowing how to write G code. Okay, I think that's it. Now we get to test it and see if I made mistakes. Now I'll put that down there, have space. Go ahead and renumber it before you start, of course. Edit, renumber. Do it. And let's see if this thing actually works. Turn your optional skip on. And then verify program. Insert tool 1. It's going to do the dip. Finish cut. Goes back, says okay, paused. Now we're going to flip out sequence, take it all out, flip it around, and it's going to start again and do the tapered part over the top of this, but you got to imagine the handle's actually on the opposite side. Okay. Now we're going to see, you can see the thread cutter, right? So basically that's pointed like we talked, and that's going to go down to right into the part, or right on top of it. It'll just be barely touching it, and then it'll okay, now it'll start threading, and it should do the whole thing. Now it doesn't actually show threads on this virtual machine because this is like Atari 2600 style, right? It's pretty old school, so. But it should look like that dip that we have here in CAD, and it did. No errors. That looks really good. And if you zoom in there, it should be tapered. We did it right. Well, and that has to go through the whole thing, of course. And you can see a slight taper to it. Okay. Why is it right there? I don't like that. So let's run it one more time here. Okay, it was just something with the video. Okay, so remember, you have the machine info open. Sometimes this gets shut down. That's just open with the view tab right there, machine info. And when you run it, if you made a typo, which I usually do, which got lucky this time and didn't, you can find it real fast on here, right? Because it's telling you exactly what line it aired out on. And then you go back to find your, like in this case, N5. So I go find N5 and say, okay, what did I do wrong there? And it's usually leaving out a decimal or flipping a Z or something like that. Putting a space between the Z and the number. Doesn't like that kind of stuff. All right, so that's the program and the drawing are both done. So the next lab will be basically recreating this from your hammer head. Okay, now you remember, so this tells you where to put the circle. So you'll do an offset of 1.375 up and then 1.5 over, and then 1.1 and 7/16, so 1.4375 up this way, and that'll give you your location for your circles. Okay, and the circles are the same as they are over here, because I think they were 1 inch or something like that, 1 inch typical. So these are 1 inch typical circles as well. Okay, so that's how you start out. So draw that thing based upon this, not this, okay? But you should end up with this, right? And then basically it tells you your threads and all that. So that's just offsets down and over for your threads. and they're all right here. Right, so the threads are basically going to be the total length of it's 3.875, and you're going to go a ½ inch back for your threads. The diameter of it's 5/8. So try to create this. There's no taper, so it's a lot simpler drawing, and you don't have to worry about the hole that's in it for the handle to go into. We're going to do that on a separate process. So try to draw it all up first, and then try to write the code exactly like we did the handle. Okay. It tells you how to, you remember the pitch is going to change. It's 1/11 instead of 1/, I think the other one is 3/18. So it's 1/11 instead of 1/8. So make sure you change the pitch when you do your G32. Okay. And somewhere I tell you exactly how much this must be the next one. Okay, there is a video. It's on the lathe threading, okay, or the hammerhead. So there's the information for that. This tells you how much to drop it. Right, evidently we did the same amount on both, okay. So that's what we did 10 off instead of, since we did 350 this time. Otherwise it's the same.